All right, y'all, so this is where it all comes together. This is the last one, which is piecewise functions. So we're going to take everything that we've done with functions and transformations and put them all together. So a function that's made up of several pieces from different functions is called a piecewise function. Okay, so what does that look like? So down here, you see we have a piece of a function here and a piece of a function here, and this gives us the domain of those functions. So we're going to have part of a function up to 1, and then we're going to have another part of a function after 1. Okay? So the important part about this is that the piecewise functions may or may not be continuous. And what continuous just means is that there are no breaks or holes in your function. So it may be touching, it may not be touching. It's okay, it does not have to be touching, okay? So there's a couple of different thoughts on this, but I'm gonna show you how I like to do this. So I'm gonna take this first function and I'm gonna keep this my pink function here. And what we know is that this value of 1 is super important. This tells us where the function ends. This says all x values up to 1. So if we look at 1, this first part of this function, which we see is a linear, is going to be graphed less than 1. So if I look at this xy value and I have a value of 1, and I plug this value of 1 into my graph, I get 1 minus 2, which is negative 1. So I know that on my graph, I have this ordered pair that is 1, negative 1. And because it's equal, it's going to be a closed-in circle. So remember, less than or greater than, we have the closed-in circle. If it's just less than or greater than, we have an open circle on our graph. And this tells me it's a line. So if I look at this, I have a line with a slope of 1 and an intercept of negative 2. So I have an intercept of negative 2 and a slope of 1. Well, this tells me where the line has to stop. So I know that since it's everything to the left, all my negative numbers, I could continue to put points on here, but the bottom line is my line is going to look like this. I have a line, intercept of negative 2, a slope of 1, and it ends when x equals 1. Okay? So I'm going to do this second line, I'm going to do this in purple. And here I have my x and my y value, and I know again that this is 1. So this is going to be where it starts because it says when x is greater than 1. So I'm going to start at 1, and it's going to be all the values to the right of this point. Okay? So when x equals 1, my point is 1. So I have 1 squared, which is 1. So here I have an ordered pair 1, 1, but this is just greater than, so my point 1, 1 is going to be an open circle. Well, I know that this x squared graph is going to be a quadratic, right? It's going to be a parabola, but this is a parabola that's this is just a parent function, x squared. So if I look at this, I'm going to use a pencil here. Technically, what I have is I have a function that's going to look like this. And I'm drawing this very lightly because we don't want all of that. All we want is what happens at 1. So what happens at 1 is that I'm going to have my parabola, and my parabola is going to go up. Sorry, it's going to go up like this. Now, if you're confused, you can look at this and say, okay, when x is greater than 1, so when x is greater than 1, a value greater than 1 is 2. And if I plug 2 in here, I get 4. And this point here would be 2, 4. So technically, my point should have been right here to get my parabola to go up. So let me change this real quick. So I'm going to get rid of this. Now, that part is not so important. What's important is that this is showing this curved line is not linear, that's showing this curved line that I have right here, okay? You don't need to do this, but you do need to see how it fits into whatever the parent function is. All we care about is what's happening right here, okay? So if you're going to graph the whole thing, you need to either erase it or make it super light pencil so it's super clear where your function is. All right, let's look at another one. So here, we see that this is another line, and this time my line is going to start at 0. So if it starts at 0, my first place is going to be 1. So 0, 1. Oh, it's going to be an open circle because it's less than. And what I see here is that I have a slope of 1. It's going to be less than with this intercept. So my line is going to look like this. Okay? So now we look at the second one, and this is also a linear function. It's also a line. And I also care about where that happens at 0. So if I plug this in, I still get the point of 1. So that's this point. So now I'm going to kind of color in that point. And I have a slope of -3. So from this point, I'm going to go down 3 over 1, down 3 over 1, and my line is going to look like this. Now, two things I want to talk about. This function, I have a break. So because I have a break in this function, that's what this says up here, this is not continuous. Here I have no break. So I had a hole for one and then I color in the hole for the next one. So this is continuous. Oh, sorry about that. That is continuous. Okay, let's flip it over. All right, so here I have three different things. This is getting a lot harder. So I have a cubic function, I have an absolute value function, and I have a quadratic. So I'm going to start with just this guy, and I care about what happens at 0. So if I look at this, when x equals 0, y equals 1. So my first point here is going to be 0, 1, and that is going to be an open circle. Now, that is also part of my parent function. So if I look at my parent function, this is a cubic function, so a cubic function looks like this, with a vertical shift up. Well, this is my vertical shift up. So my function would be down 1, up 1, right? But I'm not going up 1 because this is my ending point. So this part of my function goes through this point right here, 1, 1. So if it looked like this, it's now going to look like this. Right? I don't have to do the other part of it. If I was doing the whole thing, it would look like that. Okay, so let's go to the purple function. So the purple function I have, I want to start at 0. So I'm going to have 2 points here that I'm going to start with. I'm going to start with 0. I know that this is an absolute value function that is facing down. But when I put in 0, I get negative 3 in absolute value bars plus 2. So this becomes -3 plus 2, which equals -1. So this absolute value of -3 becomes a positive 3, but I still have a negative out here, so it stays negative. Now I also want to evaluate this at 2 because this point right here is my start, but this point right here is my end. So this is going to be a line segment. It's not going to have an arrow on the end. So when I plug in 2, I have -2 minus 3 plus 2, which is -1. So -1 plus 2 is a positive 1. So this one's easy because it tells me where I start and it tells me where I stop, and I know that it's going to be a straight line because an absolute value is going to give me a straight line. So my first point is 0, -1, and that's going to be a closed circle. And then my second point is 2, +1, and that's going to be also a closed circle. And I'm going to connect these two lines, just like this. Now, what I'm going to do is just show you if I was just going to graph this without using anything in a table, my vertex of this happens at 3, 2. So at 3, 2 is my vertex, and I know that my line would go down. So my line would look like this, right? So it makes sense that this is part of that absolute value function. All right, so let's look at this last one. This last one, I'm just going to do this in black. And I know that this is a parabola. And it's a parabola. I'm going to do my ending point right here. My starting point is actually what this one is. So this becomes -1 squared, which is 1 plus 1, which is 2. So my point here is 2, 2, and it's an open circle. So I have this point right here. Okay. So let's think about what this looks like. So this vertex of this happens at 3, 1. So I go here to 3, 1. This is my vertex. So my graph would be up 1 and then over 1. So my parabola would look like this, right? And all I care about is this is my starting point. So this point and this point are still going to be part of my parabola. So it's going to look like this. So you have to be very logical with your points. You could create more points here if you need to, but really all you're doing is you're checking your endpoints If you put your endpoints on, you know where your start and your stop is, and then you can go back and look at what your parent function is. Okay? So now what we want to do is we want to create the equations from the graph. So without a doubt, the easiest way to start is to put your domain. So this is the domain. Remember, these are my x values. So I want to identify my domain. So here I have two functions. I'm going to just make this my purple function, or my pink function, and then this one would be my purple function. And I know it's kind of hard to see, but I have 1, 2, 3, 4. So my domain on this pink function, which is my function that is going left, so this is my function that's less than, is going to be x is less than 4. And the reason why it's just less than is because this is an open circle. Now my purple function, which is this one, is going to be x is greater than or equal to 4. So again, I'm looking at my x value, and that's where this number 4 comes from, right here. Well, what I see is on my pink is that this is just a line, and if I look at this, it looks like my slope of the line is up 1 over 4. So if I'm going up 1 and over 4, then my slope would be 1/4 x, and my intercept happens right here at plus 2. So I'm just looking at the line. What tells me where I start and stop is this part of it. Okay? Now I'm looking at this, and this is another line. This just happens to be a horizontal line. So if I have a horizontal line, if you remember Hoivuk, so horizontal line, I have a 0 slope, and it's a y value, and this tells me it's y. So this line right here is just 1. So this would be the same if I look at this purple line as y equals 1. So all I have over here is just the 1. All right. So this one, more challenging. So here's what I have. I have this purple line right here, and it looks like that's the ending point. I'm going to use a highlighter on this next part because I think it's easier to see. This is the second part of my graph, and then the last part of my graph is this guy right here, this pink one. So I have 3 parts. So I'm going to go back up here again, and I'm going to identify my, my domain. So this goes to this point right here, which is -1. So my top graph is going to be x is less than or equal to -1. Now I don't see any open or closed circles, so I'm just going to assume that this is a closed circle on the purple. Okay? Now my yellow graph is going to start at -1, and it's going to go over here to a +2. So x is going to be between -1 and +2. And then my last graph, which is the pink one, is going to start at 2, so x is greater than or equal to 2. Now, here I have greater than or equal. Here I just have less than, and here's equal. So if you remember, if we have a vertical line, our functions are not going to overlap. So it doesn't matter. This can be less than, but then this would have to be less than or equal. This could be less than or equal. This would have to be greater than. So we can't say that they both equal -1. And since we don't know which one equals -1, we're not going to worry about it. We're just going to say, okay, one's going to equal and one is not. Same thing here. One's going to equal 2 and one is not. So if I look at this, I see that this is a line. So for me to have a line, I have to have a slope and I have to have an intercept. So I look at this and I can see what my slope is. It looks like it's up 1 over 1. So if I do this again and I go up 1 over 1, it looks like I would hit my graph right here. So if my slope is up 1 over 1, my slope is x, just 1, so 1x, and then I hit my y-intercept becomes a 2. Okay? So now let's look at this parabola. So what I know about this parabola is that a standard parabola, I'm going to write this down here. So a standard parabola looks like this, right? I have a vertex at 0, 0, and I go up. Well, here, it looks like the vertex still happens at 0 on the x, but now I've shifted up 2. So I know that I'm going to shift up 2, and I know that this goes down. So my equation is going to be -x squared, because it's going to go down, but my starting point is not here at 0. My starting point is here at 2, so I have +2. And then my last part of my graph is another horizontal line, so this is just going to be -2. Okay. Now, one more part of this, and then we're going to be done with this for today. So here, again, this gives me my domain. So all of this is the domain of the x values. And what this is telling me, again, is this is f of x. We go back to function notation. So when x equals -1. Well, when x equals -1, I have to figure out which one of these functions makes that true. Well, there's a -1 here, but this is just less than -1. And this is when x is greater than or equal to -1. So I'm going to use this function. So what I have here is I have the square root of -1 plus 1, which is the square root of 0, which is just 0. So the value of this, that's what we're looking for. We're looking for the value of the piecewise function when x equals -1. I want to figure out which part of the piece I want to use. I want to use the middle one. I plug in -1, I solve it, and I get 0. All right? So this next one says, what happens when x equals 0? Well, when x equals 0, I have to figure out where does that fit here. Well, if I look at this middle part, I have -1 and 3, right? This is my middle, and 0 is in between. So for this one, by chance, I'm going to use the same function because 0 is between -1 and 3. So what I have here, sorry, I'll adjust this a little bit. So what I have here is the square root of 0 plus 1. I plug 0 in to this, so the square root of 1 is just 1. And now we look at this last one, and it says when x equals 3. So when x equals 3, I'm using the third part of my piecewise because it's greater than or equal to 3. So when I plug that value in, I get 3 squared, which is 9 minus 4. And in the denominator, I have 3 plus 2. So this gives me 5 over 5, which just equals 1. So 3 major concepts here. One is when you have the piecewise function, you can find this algebraically using function notation. The next one is creating the equations from the piecewise function. And the third part is graphing from the piecewise equations. So you need to make sure you can do all 3 of those.